So good morning, everyone. We really appreciate your presence over here on this weekend morning. And first, we would like to thank Cloudera and Thoughtworks for supporting us with this event. And it is a great time to introduce. Previously, we was Kubernetes User Group India, and now as the industry flows towards AI, so we have rebrands itself. So we are now CubeSmart and AI User Group. So this is our rebranding logo. This is our new logo and new name. So this meetup we have started very back, like in 2021 in Singapore, and it started spreading across the world. So we have great presence in more than 7+ countries, and like you can see the 32,000 plus members we have. And if you go on the LinkedIn, you can able to see these are the few things you can go through. This is the link tree. You will check this link tree. You will find all the links over here. So we also offer we are partner with Cloud, like Code Cloud. So we are very long-term partnership. So Code Cloud is basically we generally sponsors coupon code for courses around Code Cloud. So Code Cloud is a platform where you can go and learn about the Kubernetes cloud native ecosystem, and you get into the great hands-on sessions and live hands-on session. You find a really amazing platform to learn about the cloud native and Kubernetes ecosystem. So there is a program called Cube Astronauts, where you have to complete the 5 ultimate Kubernetes certifications. Then you will get the tag of Cube Astronauts. So basically, the founder of KSUG.AI is basically the ambassador of Cube Astronauts. So if you are interested in doing Kubernetes certification, so we also provide the hamper of coupon codes, so you can grab it with very less cost. So this is our mission. Like as we rebrand, so but we stick with our last mission. Yeah. So coming to the AI global footprint, so we have started from the Singapore and like spreading across the world. So we are more you can see we are here like more than 8+ countries, and we are still spreading across US and some other countries. So you can find the upcoming meetups over here, like as we are hosting. Yes. So if you go on like KSUG.AI, so you will find the more meetups across the world. So meet our team, this is yeah, sure. So Yongkang, he's the founder of KSUG.AI, and he's both people behind just next to the Yongkang. They are the global member. So they are handling all the global operations of KSUG. So this is India team, and this is me, Anand, and my co-organizer Kunal. So we also work in a volunteer way because we need support of community to grow. So we are always open to people who really want to contribute to the community and really passionate about the contribution towards the community. So we really encourage the volunteership who can come and help in any way possible. So these are all volunteers. So you already find the agenda of the events. So you can go through on the meetup page and this. So these are the upcoming events which is on the way. So 29th May we are hosting in Canada at AWS office. Like as we are hosting today at in India at Thoughtworks. So you can follow the roadmap of the events. So these are the open codes. So if you are doing AWS certification or or Kubernetes certification, you can grab the open code. And we also offer 100% Kubernetes certification open code, which is very rare because the Kubernetes certification is still like it's very costly. So you can participate in like lucky draw competition we usually organize on our LinkedIn page. So you can follow that and you will easily grab that. So yeah, we have already partnered with Cloud, and like previously we have partnered with CNCF, as you already know around. So we are not like still a partner with CNCF, but yeah, we have the long-term partnership with the Cloud, so you can grab their open course. And like if you are really interested in reading books, so we are also partnered with Packet, so you can go and get their coupons, and you will get books with the very less cost. So these are the things you can follow. By using this link, you will get all the links. So this is our like co-founder, and he's ambassador of Cube Astronauts. So these are the social like if you want to join as a volunteer speaker and as a sponsor, so you can follow this QR. Please hold that. Sure, sure. No, the one before this. This one? No, WhatsApp. Yeah. So guys, today we are also playing quiz at the end. So those who are the winner, they are going to get free Core Cloud subscription. Like top 3 people will going to get free Core Cloud subscription for the 6 month. So this is the amazing opportunity. You can grab it while playing the quiz.
So as a human being, putting into the contrast is key to it, because we all inspire from AI, we all inspire from our life, and then we try to model AI. So understanding ourselves is a critical thing which we generally do not do, and that my job is to correlate that and through an analogy. And observability, when we talk about, I'll come back to this part a little later. When we talk about observability, do you know that we all have observability built into our mind? Six sense nahi, normal senses also. Six sense are, there are few privileged, they have extra power. Up to seven sense I am aware of. So observability is built into our mind, and I'll try to show how does it work and how do we do it. So for example, I'll talk about myself, and you can correlate yourself also, because I'll be greedy here. I don't want you to be greedy at any point of time. So the blame is on me. I come across multiple people, but I handpick few of them as my friend. And again, from those friends, if I get into a situation, I can say, for example, I met an accident in Whitefield, right? And I have few friends in Whitefield, Jayanagar, JP Nagar, all of the Bangalore, and across India also. So when I get land into a situation, what do? I remember my close friend, right? Who can help me at that point of time. How do I reach to that conclusion? There are many friends, many society friends, but I reach out to a few of them. Why do I do that? Because I know the person who I'm calling is definitely going to help me, right? That is what is all observability all about. And putting into the youth context, you might be dating many people, but you select one with whom you want to have your life, right? So our observabilities are by default on always, but when we model in the system, we call it observability. Okay. And the point that what I wanted to highlight here at the same time, there is a, I was looking at LinkedIn posts, likes and all. I found there are some confusion about LLM observability versus LLM development as observability. If some of you have developed any model, you would have come across hyperparameter tuning, right? How do you do that? You do that using some tools. Weights and biases are one of the prominent tool. And like that, there are many tools where you do your hyperparameter tuning. So this talk is not related to that. We are talking about an observability system, which is a model is already in production, which is fine-tuned already, and those we are going to consume, right? So this is the left part of the in this case. Okay, for you it is the right part. LLM observability I'm going to talk about when model is in production, and that we're going to talk about. Scenario I told about the friend, and so you would have seen the current trajectory of technology progression. It goes to keeping LLM in the center. All around it, lot of apps, agents, and whole ecosystem is getting built. So kernel is what? So if you are from the OS or system side, you would have heard about the OS kernel. So right now the AI kernel is going to be your large language model. Around that, we are developing certain peripheral apps and sub tools, certain subsystems, and that is evolving, which we don't know what else to come in future. We'll probably specialize some of those and we'll try to consume it and start serving humanity or other way also. So typical challenges when we are productizing our concept using LLM at the kernel. So what are the things we need to keep track of? When we have friend, we have to go out to the weekend, spend money, party. That's a cost to us, isn't it? Similarly, there is a cost associated also when we start consuming LLM models as well. So the first one is the typical challenge that we encounter while developing apps or agents typically. Are LLMs free? They are not. So there is a line here. Even intelligence, when made artificial, demands its price. So these are not free. We have to burn either, if it is locally deployed, you have to burn your laptop's GPU, CPU, or if it is on-prem, it's a systems, your company enterprise system, or if it is hosted managed service, then that will also charging you money. So those are not free. So if something is not free, then optimal use is must, so that we do not burn our cash. Another thing is, are all the friend that I remind when I was in a situation in Whitefield, can I call him when I'm in a different situation? No. Why no? Because if, say, for example, I'm in a medical situation in a hospital, I need someone who is smart enough to deal with insurance, medical treatment, and all. So I'll call someone who is qualified enough to deal with that situation, medical situation, right? So the scenarios are different. In the very similar way, all LLMs are not good at doing what they're supposed to. For example, putting it again, contrast, connect with me, because this is the moment you start correlating this day-to-day life activity, you can model a lot more better things, whether it is a usability or writing your own model or specializing your own model, right? So the point is, not all models are useful equally. Giving an example, ChatGPT is good in a textual manner, but it is not good. I haven't found it is to be good with respect to the image generation. Okay, but when I start using Gemini, it is too good in image generation. It's too smart. It understands me because I have used the same email ID to register with Gemini, and it understands me very well based on my search. But whereas ChatGPT is not. But in general, their generation format is different compared to the Gemini. Gemini is really good, and at the end of session, remind me. I'll tell you how did I contrast it out. Okay. So as not all models are equally equipped to serve you better, so you have to choose which model is effective one for your use case. That is also an important part. Here, observability. I'm Ram, so I'll take the wine example. So observability, we all have been using, even in our normal system. Kubernetes guys, those who have used, they would have used the Prometheus Grafana and all to monitor how the system is behaving. OS also throws some parameters, and other applications are relying on this to understand how data has been churned or consumed, right? So observability is a old wine bottle, and the bottle is labeled as AI. Understood? So keep that in mind. Nothing is changing except the format or the usability part. Rum GPT. I have developed this for this talk to have because I wanted to try out something what has been tried out in enterprise and I to demonstrate you better. So I have written this Rum GPT, and I'll give you a tip while we go through the slides. I'll give you a tip also why it is important to have your own as a developer community. Why it is important to have your own GPT format. Okay? When we talk about the matrices or observability, these are the key metrics that we need to keep in our mind and start observing. So one is the latency, how much the time take to round for a round trip, or your prompt versus your total output. I will slightly deep dive into all these topics, but each of this topic can take whole session. Trust me, there's so much to cover in this case. Okay, cost, request error, user feedback, accuracy, and automated evaluation. I tell you once again, each of this topic is a subject of discussion for a whole session. So latency, when you submit your prompt, the whole round trip, when you receive last token of your output response, that's the whole round trip. That's called the latency. Due to the lack of time, I will just rush through, but this slide will be available for you to have a look. And I'm available on LinkedIn. If you want to have further more discussions, we will definitely do it. I'm constrained by time. So this, and if your latency is high, in a general sense, user experience is bad. User will not stick to you. But in case of LLM, that is not absolutely true. For example, when we are doing some research work, a research work takes few hours altogether. We cannot optimize it to give me a response in few seconds. But otherwise, if it is a general discussion or general prompt, probably you can expect a quick response from them. So you have to be judiciously deciding which latency is going to be useful for you. Latency that we talked about, this is what you submit a prompt, LLM churns it, and then gives you the bunch of output through the tokens, and that gives you an idea. So the today LangFuse is the one which I have used to demonstrate here. I'm not sure if, how time I can manage with, but at least I have shown here latency. If you can follow my, you see here latency. So 2.47 seconds. And the model I have used is GPT 3.5 Turbo for the sake of demonstration here. And so other details, as we progress, I'll show you. Time to first token. As I told you, user interaction matters. So if you wait for the whole time to prepare the response and send it to the user will run away because of the time. So what do? We tell stream it. The first token that get churned out, that means your prompt is understood by LLM. And now it is trying to cook your response. The first token or the first word that land to your prompt or your output is called the first token. And that is important to measure because by then system has understood your prompt. So that matters as well. And then slowly LLM starts sending you via stream all the tokens followed. Here again, if you see here, there is a time first token. Is it visible to all of you? The first token. And in case of this, if you see here, time to first token is 0.73 seconds. Overall latency is 2.47 seconds, whereas the time to first token is 0.73 seconds. So why it is important streaming? Why to use stream? Because it keeps your user engaged. Something is coming, right? As you read through, it will keep coming. So that is important here. Cost part. If you are using managed service or the GPT or Gemini, for example, then in that case, your tokens are calculated. Input token, output token, and cumulative they give you. I have shown the calculation here as well. So that also we have to be mindful how these are calculated. But when you are using your local system, so for example, in this demo, I'll show you, I have used OLLAMA framework and Llama 3.18 billion parameter model. And there you will not find token concept because it's locally deployed. Token doesn't matter. It's all depend on me. So here is the cost shown. I've used the managed LLM service with GPT-3.5 Turbo. These are the actual price as on May 2025. Prices are input is per 1,000 token 0.005 and here 0.15 to output token. And if you put the calculation, you get the whole value. This is the for a submittal. This is the what value we get. Okay. And if you see here, I have demonstrated this part. 425 input tokens, output tokens is 200. And this is what my prompt is all about. And total cost says, yes, summation tells me the total cost, $512. Idea. So while working on it, I realized it is, how many of you have subscription of ChatGPT? You have? Or not? Hello? How much is it? So it's like a $20 per month subscription. Whether you use it or not, still that is limited to $20. Whether you extensively use it, does it allow infinitely to use it? No, that means there is also a cap. I found while working with the APIs, it is a lot more cheaper. The calculation I just showed about the tokens. So if you put it into your own RAM GPT the way I have created, you can create your own. It will be a lot more effective. So instead of using subscription, okay, that is probably one of the takeaway as a developer. There's a Streamlight framework. It lets you. I have developed the RAM GPT using Streamlight, and it is a lot more easier for you to have the full-fledged app, and that gives you a lot of data. Okay. So that is one of the key takeaway as a developer to the developer community from this session. Okay. Request error. These are nothing new as these are managed services, so their failures are inevitable. Server might go down, tools used might go down, and there could be network issue. Data center might be on flood or fire. There could be a possibility. So making high availability would make a lot of sense. This is normal software engineering, nothing beyond this. So how do we recover from that is what the key takeaway. So I have shown here example also. Here, if you see, my model was not ready and available. So Llama 3.18 billion parameter model, and it was not available. So it captured the error. I'm using LangFuse. I'll quickly show the demo also if my time permits. User feedback. You all would have seen ChatGPT and Gemini also, thumbs up, thumbs down, and you can even write some comment also if it is not satisfactory to you. They ask you the questions. User feedback is very important, especially when you are dealing with large language models, because that enable service provider to understand if it is serving better. The use cases are huge. No model can try those all out. Humans are creative. So we go creative, we write questions, but keeping the semantics same, a lot more things can happen and expectations are different from different people, right? So user feedback is important. That is also can be factored in using the LangFuse as an observability parameter. Accuracy. My accuracy is different from others' accuracy. What do I mean by that? Say, for example, I'm asking for this presentation, for example, if consider me and Sasi Tharoor beside me. After me, Sasi Tharoor is there to give this tech talk. And if I have to prepare a slide deck, my English should be normal English. But if Sasi Tharoor comes and stands here and asks ChatGPT, give me a slide suggestion, then how you ChatGPT is going to give like normal English? But Sasi Tharoor is not happy with that because his English is phenomenal, and we all love to listen to that, right? So for Sasi Tharoor, the accuracy level could be different. What is his expectation compared to my expectation? So in that case, Sasi Tharoor require a different accuracy level, and that is he will refine his prompt. He will give me a British English or legacy English, Shakespearean English, like that, he will ask, and probably the prompt will provide that information. So accuracy matters, and accuracy matters to the individual perception. So we have to be watchful about that if when we're developing a LLM apps or agent-based framework. Automated evaluation with the, say for example, one of you develop a LLM app and it's become very popular. Would you be able to scale to cater to the billion or millions of users at the same time or requests at the same time? It would be really difficult for you to manage with. So you need some automated way to figure it out if the prompts given and output provided are good enough to deal with. How does Google do it? Google search has lot of people are using Google search. Then what do you think? How Google would be doing it? There is an automated framework which takes care of whatever been searched and the search results are relevant or not. That is all automated. There's no human intervention unless there are exceptional cases where human need to analyze where something going wrong. So similarly, automated evaluation is very important, and LLM as judge is the way typically to achieve those. Observability tool that whatever I have shown you, I have used the LangFuse, and why LangFuse and why not others? I found a lot more feature in LangFuse compared to the others. And it is so much so that this session is the chapter 1 of my whole conversation. There will be some more following chapters, chapter 2, chapter 3, which I'll go further detail. And 30-minute or 45-minute is not enough to cover all those in one go. So it's just the chapter 1 conversation. So I like this tool personally, so I have shared here. They're not funding me, by the way. Okay. As we talk about, and as a software engineer, what do? I have total 20 plus of experience. Whereas engineer, any system that I interact or use or any tool that I use, I always think, how does it work? What are the underlying components? So this gives me an edge to understand system better, and wherever required, I can do the fine tuning. Similarly, I'll talk about the LangFuse components, and it will be interesting for you also. LangFuse web that we interact, it gives you a web server so that we can interact with it. LangFuse worker that does backend bookkeeping works, for example, sending mail or revisiting the events, streamlining those things falls under the worker purview. ClickHouse is another columnar database used typically for analytics purpose. So your observability is nothing but analytics, and analytics transactional database or row-based database may not scale that well. That is why ClickHouse has been used here. Redis and Valkai. Valkai is a open source fork of Redis, and Redis is used for caching purpose in memory. Blob store, any image search or any kind of PDF search or anything of that sort happens, it lands to the object store. In our case, as I have deployed locally, I have used Mean.io and Postgres for transactional purpose, user management, organization management, and project management purpose. Okay. So here is the one which Docker Compose I have brought up. All the components that I have talked about are listed here. This is what the architecture looks like. User sends a request, lands to the web server. If it is user specific, go to the transactional database. If it is events or metrics that need to be captured, that goes to the ClickHouse. And if it is if it is an artifact, image or PDF or Excel sheets or so, it lands to the blob store. And if we have more than one LLM models or LLM is outside, we can write our own gateway as well.
So with that, I just wanted to take some of your time, and sorry for the delay. I'm standing between you and the lunch. The name of the group is KSUG, and for some strange reasons, they are dropping the K or the 8, and they are making a new name like KSUG. So it's a Kubernetes community. I believe that's how it started. So kudos to you guys that for turning up, because you realize it or not, Kubernetes is predominantly the open source driven initiatives. But there is a relationship with Google. Anybody remembers it or anybody knows it here? How is it? What is the common between Kubernetes and Google? Yeah, so Google was playing around with the Borg, which is Google's internal engine. And then there were a lot of people who wanted to use Google scale of compute. And they were saying that how can we reach out to the Borg? So Google tried to even open source the Borg. But then they realize it's such a massive setup that it cannot be open source. And then they said that, but we do need a container orchestration platform. So some of you who knows the history, Linux has the container, even the Google has a lot of open source contribution, even the Linux containers. So bunch of engineers come together in 2013. They say that we should build something for the world. And like everything else in Google, it has to be planet scale. 2014 June, you get the first GitHub comment, and just soon after, the GKE forms. So the correlation is symbiotic. GKE is Google's managed Kubernetes offering that is equivalent of any other cloud, and open source Kubernetes was sort of brought in from there. And since then, Google has been at it. Some of you who kind of follow it closely. So all the key features evolved over a period of time. So Anthos and GK Autopilot. So what you're seeing is this slide is the interchangeability. So something which happens in Kubernetes, soon after it happens also in the GKE, and that's a conscious decision because we want to be the open source community. And with that, Kubernetes last year has completed 10 years. So I believe a big round of applause for Kubernetes. Thank you so much. So I kept it as a trivia that what is the latest version of Kubernetes, but then I thought it is too much. So 133.1 is out. Interesting tidbit here is that the open source community uses GKE to build the open source Kubernetes. So that means previous version of, or some stable version of GKE used to push the latest one. Partially because nobody else has that scale, partially because nobody else wants to contribute at that level. With that, like I said, so GKE has completed 10 years. You clap or not, it is your choice. I'm not going to ask for it. The correlation with the open source, so although this is a little bit of slide which says that Google contributes very heavily on the Kubernetes part of it, but I have a ask here to this whole group. I mean, so you've come here on Saturday. And this whole event has been kind of arranged in a nature of open source. You come, you share, you learn, and then you teach somebody else. So from India, as a fellow Indian, I want to urge you that contribute more in open source. And that also means that you go and convince your organizations to contribute more in open source. So next time that we don't see only the who's who, like Google, Microsoft, and all. And by the way, this is not the true representation. There is hundreds of individuals and even more, organizations which are contributing to bigger open source where we build everything, and also to the something like GKE or Kubernetes, which sort of follow it as a product model. How big a container platform could be? I mean, so the real answer is nobody knows. The one which we know inside at least Google is we could be like really large. So before anything comes out and you see it in the things, that means even if we are doing the open source testing of the Kubernetes, we truly push the boundaries. And you can see everybody, like who's who. These are predominantly the Google services. They use the internal container platform before we go and tell somebody and say that, hey, would you like to use our system? That was the unit per week. I'm going to skip this slide. There are certain other things are evolving, and this I heard the previous set of people to talk about platforms and platform engineers and the things. So whichever service provider you're going, you have to look for certain kind of things. So look for the scale, because one thing, as I will correlate with AI, is that it is going to push all kind of boundaries. So you think in terms of tokens, you think in terms of models, you think in terms of so many variety of like LLM and the things. But you have to remember that underneath there is a compute. That's where the whole power is coming from. There is no LLM which does pretty well without CPU and for sure without GPU. So those are the fundamental things. We call them infrastructure. In that sense, if there is a real hardware, then what is the Kubernetes is? Anybody would like to give an answer? What is Kubernetes? 101. So it sits between the hardware and your application layer. This is the cross simplification, you understand it. Because the hardware and the scale of the hardware at some point of time becomes so complex that you can't just use your application. In that sense, if you say that the new modern generation container platforms are the operating system of the operating system of everything which you work on, your SaaS platforms, your models and the things. AI is not happening in isolation. AI is not only pushing the boundary that you can get the cool ChatGPT and Gemini and all those models and you can read the image and blah, blah. AI also is pushing the boundary downwards. That means how well you can put your infrastructure together, how optimized you can do it. By the way, many of you do not realize, or maybe realize, is that the word which we say price per token, it comes from that, the cost of infrastructure plus electricity plus everything else. When I'm saying infrastructure, I'm saying over sense of infrastructure. The concrete, the place, the people, electricity, everything put together. So one thing which you have to remember that to make that small joke to tell you from the ChatGPT or any other LLM, there are a lot of things which goes underneath. Because it's an open source community, I can appeal to it. Remember there is a greener aspect of it. If you're using anything that do the scaled compute of this kind, you also have to be environmentally conscious. So Kubernetes 101, again, 4-way autoscalers. Not all the managed Kubernetes has it, but this is the design of it. NAB has been very popular in Google words, some people call it GPA, or in Microsoft AKS. Amazon uses slightly differently. Point here is that to show this slide that nothing happens in isolation, you need to push the boundaries. How big the boundary could be. We used to be very happy with hundreds of nodes. This is a typical mid-sized organization. You said thousands of nodes. This is your popular e-commerce website in a day. But what about the people who scale even faster than that? That means thousands of nodes per 10 minutes or per second. So this is the scale when you start pushing it. So like I'm saying, we don't know what are the boundaries is. It's just that in Kubernetes world, in Google world, we are ready for it. So AI, this is what we have come here to talk, because very soon, if not, Kubernetes will be seen as the fundamental building block to AI. This is how it is going, because I have heard some crazy number, you guys can disagree, but feel free to raise it. 80 or 90% of the AI workload is happening on top of Kubernetes. So there is a slurm, and then there is some more automated cloud, the serverless environment. But when you will become serious, you will come to Kubernetes. This is what has been the things. Part here is that you need to push. So even if you imagine the upward, the application layer is sexy. I don't know if I'm allowed to. Imagine that hardware part is also evolving very, very well. So there are people who are looking at the platform and below. There are so many things happening for it. And price of, if you're not hearing the price of a token, or how well you get a token against a given dollar value, is going to become the ultimate game. Many of us are not realizing, but that's where it is going. And that's the game which you see that NVIDIA's GPUs prices and blah blah and everything else. Skip. A lot of things which are evolving. Your traditional load balancer will not work against a very scaled system. And this I'm not even talking about the training. There are probably tens of people in the world will do the largest scale model training, frontier model. Millions of people use the inferencing. At that point of time, what load balancer you're going to use? Will it work? Who's thinking about it? So in GKE world, we have something called inference gateway, which is not only aware of your traffic, but it is also aware of the state of the GPUs. And it is querying that, and depending on that, it is pushing the boundaries. How would you obtain it? I mean, so that's the whole question of it. So DWS is both, Amazon Google is trying to make it open source, but it is available. I'm trying to say everything with the touch of open sourceness. Obtainability. How will you get a GPU? I mean, it's very nice that you went to ChatGPT and asked something. Try doing it for your organization or try doing it for your startup. First thing you will go and ask that, how do I get a GPU? So GPUs are in short availability, at least for 24, 25. Maybe coming years, they will become better. But until that, you need a smarter system. So somebody has to evolve that part. Google has a version of OOM, which is called Tensor Processing Unit or TPU. The price, which I'm saying is right-hand side, the cost and the performance. These are the three parameters. That's how you will gauge your infrastructure. And this I'm saying for the people even if you're an application developer, remember that underneath there is a platform, and it is your job to understand that how well you are able to how well you are able to run your application, that is LLM kind of application. So we heard this morning about a lot of LLM usage. I'm going to skip through a lot of part here. Imagine that there is a compute class. Compute class is a declarative way of consuming even the code or consuming even the workloads. How do you know which machine is available? How do you know that which machine will work against your system? All of this, you cannot leave it to the chances. So you put up, the layers, hierarchy, you let the system decide, and this I'm telling at scale, right? With millions of parts moving around, it will become a complex problem. Fast startable nodes. Good news, you got the GPU. Try running your model on a GPU. It will take a time. And guess who is going to pay for it? You. So the companies are happy to take your money, but it is your job to remember and ask them that how quickly it's happening. So things like faster startup node saves the money for you. Even in inference world, there is two large places. If I can super simplify it: training and inferencing. Inferencing is that's where you go and ask a nice looking question or ask the major model to generate. There are a lot of people who do the training, like OpenAI, like Google, like other big guys. Smaller guys, DeepSeek did a fantastic job of putting in open source model. Quen, all the models, smaller one, 3B to 85B, all are amazing models. Scale. 4 pillars of Kubernetes: HPA, VPA, container autoscalers, and NAV. You have to ask everything, like how quickly my horizontal pod autoscaling is happening, the same machine type. How quickly I can get the job done inside it, that is your pods and deployment. Okay, let's skip. Release channels are very important. It's a day 2 operation. No, we don't want to see the demo. All I'm just saying is that how we are looking at the response time. Running a pod in a matter of millisecond, and this is 1 multiplied by million times. What if you're losing a few hundreds of milliseconds here? What will happen at the scale of million pods, which is not a big deal. Million pods are not very big number. You need to sort of be sensitive about all of this. Let's skip. These are the parts which is going, like Crow will become, I don't know if somebody is using Kubernetes Resource Orchestrator. Google is again very heavily around it, open sourcing it. This will become the standard way of consuming your workload and definitions. With that, I don't have much. Again, sorry to take your time. I will be around if you guys want to do it. If there are AI startup, are there AI startups here? Anybody? Just hit me. I would like to have some discussion. Thank you so much.